streaming so that the people who are not here can at least see what we're working on, even though we won't actually technically see what we're working on. And I will remove this screen. There we go. Okay, show me what you're working on. Which one are you on? Last one. Excellent. Go pick one. Do one on the board. No, pick one of those that you have done. Which one are you working on? CHO2. Oh, so you okay? And then you haven't been minusing the whole time, though. Oh, I don't know. That's what we'll find out once people do things on the board. Yeah. So let's start over again. Erase that, because I don't actually know if that's even true. Erase everything except for your bond. So erase all the pairs and the lone electrons. Okay, single bonds only. And then put a single bond to each one. So that's always the first step. And then you minus those electrons. Yeah, minus 6. Okay, and then which one needs more electrons? Yeah, so give the outer ones a full octet. Yep. It does, but you haven't given another bond. Okay, how many electrons did you do giving up the full octets to the outermost ones? Times 2, 6 and 6. Minus that. Now, which one do you do? Now what do you do? Are they all happy? No. No, that one is. Carbon only needs 2. It's one of our exceptions. Sorry, hydrogen only needs 2. Carbon needs 8. No, it can have up to 4 bonds, but there's 2 electrons per bond. You can't. You've run out of electrons. Where do you have to get those from? Oh, Donald, no, you have to show all your work. You have to show the little electron calculation and everything. Yeah. No, you've run out of electrons. You can't point at this anymore. You're at 0. Where are the electrons in here? Right. So its neighbors have electrons. You could take 2 off and make it a bond. So what you do is when the central atom doesn't have enough electrons, you start making bonds from the lone pairs. And then count. Does it have enough electrons now? Yeah, excellent. Show your work. Add that up. Do that one on the board. What one are you on? Oh, excellent. Go do one of those on the board. Yep, no, I'll check it when it's on the board. Put them on the central atom. Anywhere. Looking pretty good. Yeah, what's wrong with it? How many is boron happy with? You guess 6? What do your notes say? Yeah, 3 bonds. Oh, go back up again. One of the things is you didn't write it all down. 3 bonds or 6 electrons, or any combination thereof. So yeah, 6 electrons are fine. Why don't you go do one on the board? Okay. Do you have some of these? Do you see one on the board you could do? Okay. Yeah, that's looking good. Go do one of those. Go do that one. That's which ones? Nope. You're on the last step, but you haven't done the last step. Well, are they all happy? What do you do when the central atom doesn't have enough electrons? Yeah. Add another bond. Excellent. Sorry, what? What about it? Yeah. No. Because how many it has doesn't dictate how happy it is. They all want an octet, except for the exceptions. So they always want 8. They want full shells. It has 4 in its valence shell. The 6 is the total. Doesn't really apply in any particular way. So you're always looking at how many for an octet. So always looking for 8. That's its charge. You have to add 2 electrons. So right now where you put C30, underneath that you should put -2. And on this side you should put 2 electrons. Yeah. You also you didn't do any minusing, so I don't know where you got to because you stopped at 18. So I would erase all the way up to here. You've given this one way too many electrons. 3 fluorines is 21. Boron is 1, 2, 3. That looks good. So you had 24. You had 2, 4, 6. You minus that. And then something weird happened. So erase. Yeah, erase everything after 18. Because I want you to start over again and see it. Boron has 2, 4, 6, 8, 10, 12 electrons. It's just, and then get it back to where you got to that point in there. Okay, yeah, and you'll have to erase this. Get it down to the point you were at when it was 18, which would be no lone pairs and a single bond to each. Now, well, erase if you don't know how much to erase, erase all of it and take this all the way back up to the 24. And then you can just start over again. Right, and then get rid of all the the pairs on all the fluorines because you haven't you haven't taken those out. So all these little pairs. Oh, yeah. No. 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 You have 18 left. You have not. They don't belong to anybody. Chemistry is communism. All those electrons are sitting in the collective pot for everyone. So yeah, they don't have 7. They gave them up and gave them to the collective. Excellent. Now, what's the next step? Yeah, you always put it on the outer atoms first. So you give each of them 6. That will give them all an octet. So you're here, 2, 4, 6. Why did you minus 8? You give everyone a single bond. Erase all the lone pairs and erase all your bonds again. Yeah, now do you stop there or do you give a double bond to the central atom? I'm asking you if you should. Why would you get rid of all of them? What is causing you to do it? Like you're taking them from, you're always saying like, I'm going to take it from each one. Why? Because that's the way I think, Mr. Neufeld. You don't have to be even. If this one needed another bond, you would just take 2 electrons, give it a bond, and then count. Is it at an octet? So you do it one at a time. You'd never do all of them at once. You do it one step at a time. Excellent. That's the point I was trying to get at. You are done. So I was wondering, did you know it didn't need an octet? That one's now good. Is that one done on the board? No. Hold it. Yes, it was just done. Do a different one that hasn't been. Now, of the ones that are left, if you haven't gone up, pick one, do that, go and do it. If someone gets to it before you, You have to do a different one. Why you keep giving that one a double bond? That's not how it starts. Yeah, you can't do that. You just when you begin, you always put one, and then erase all this because we have to account for the charge. So you put a -2 there on this side, just like it was an element, and then on the other side, 2 electrons. It's not -2 electrons, it's -2 charge. No. Like this has to be erased. It's not 2 electrons, it's a -2 charge. So on this side, you want the charge, the -2. So on this side, you write -2. This side, right here, on the left. Right there, right underneath it, yeah. Colon. And then you write 2 electrons. Because for every -2, every minus charge is an electron. If this said +2, what would you write on this side? -2 electrons. So you're using this to account for the electrons because of the charge. That's why we're setting it up that way. Now add that up. Well, you can give one a full octet and then subtract it. You don't have to do it 2 at a time. Like you give as you go through, you give each one a full octet. Why are you removing the bonds? Oh, yeah, okay. I thought you were because you put the 2 there, so I didn't know what you were doing with that. Okay, yeah, put that in there. Get your 18. Yeah, but you're jumping. You want to minus your electrons before you start doing that, very deliberately, so that because if you had electrons left over, how did you -2? What's that? 2? No, put that back. Erase all that. It's more important to get the accounting right at this stage to make sure you don't make. So erase that double bond. Put those 2 electrons back. Than it is to get the right answer, because the accounting will save you when you don't know the answer. You have 18. You just put on a bunch of electrons. Those should be minus. You just put on a bunch of electrons, and you never minus them. Those should be minus before you do anything else. Now you have 0. That means you can't go back. That's what tells you that I should put things on here. If you minus that and you had 2, well, then you put them on the central atom, and you wouldn't have to do that. Right? And when you are moving those around, you don't have to minus them. They're still there. They were there before, and you do that. Now, I think that one's been done. CO3 -2. Yeah, upper right looks like someone's done it. Yeah. So it looks like CL4 plus looks like it hasn't been done. CLF4 plus? Hold it. Where's CL3? CO3 -2. Oh! I've put it up there twice. Never mind. So ignore that one. Hold it. And you're doing CLF4 plus? Okay. That one's been done. Whereas, yeah, this one was just extra. There's no more. I'm going to have to add one. That's terrible. No. We've got someone working on that. Okay. I'm just going to go through them. So, what? We're not out of time. Oh, excellent. We have a minute. A whole minute. C double bond OHO. That looks good. PCl5, unless there, no, I don't think there's a lone pair there. Boron is satisfied with 6 electrons, so that's good. Beryllium is also satisfied with 4, so that one's good. Notice they're breaking the octet rule. Everyone has a full 1. Something has gone wrong here. 5 plus 4 is 24. Okay. This is one of the importance of making sure you add. So iodine times 3 is 21 plus nitrogen, so that's 26. Then you add in the 3 bonds. So I'm going to do my work in blue. 26 minus 6 gives us 20. Then you put on the lone pairs. And to give them a full octet, you do them one at a time, give it a full octet, see where you get to. And that's 6 times 3, so that's minus 18. Means I have 2 electrons left over. What do you do with leftover electrons? Put them on the central atom. Is everybody happy? Yeah, so that one's now done. So we didn't need double bonds in that one. Always make sure you're including your accounting, because that really tells me if I see this and that, then I know that you really know what you're doing. This one's very well done. Excellent. It's so nice and neat as well. 1, 2, 3, 4, 5. Does that one need a lone pair? I don't think it does. That's good. And, oh, beautiful. That one's a little tricky because you have a, it's 4 bonds, which makes it look good, but it actually ends up being a double bond. That's what phosphate looks like. HBr, correctly put it around there. NO3 minus 1, that is also good. We are good. That last one, we will do next day. Woo! Thank you.